Welcome. We are going to discuss the solutions to the CAT2 problems. And this was the first set of problems to describe the graph of the polar equation r equals to 6 over square root of 9 minus 5 sine squared theta. The question 2 was about circles. Question 3 was about conversion from polar into Cartesian. And then number 4 was to discuss the type of graphs defined in the two cases. So let's briefly discuss the solutions to this first set of problems. So question 1, describe the graph of the polar equation r equals to 6 over square root of 9 minus 5 sine squared theta. Now, we are usually not happy with square roots. So let's remove square roots in the expression or in the equation by squaring both sides. So we'll have square of r equals to 6 over 9 minus 5 sine squared theta, and then I square. So this means I'll have r squared equals to 36 over 9 minus 5 sine squared theta. Now I multiply both sides by 9 minus 5 sine squared theta. So r squared into 9 minus 5 sine squared theta, which is 36. So r squared times 9 minus 5r squared sine squared theta equals to 36. But remember, x squared plus y squared is r squared, and r sine theta is the same as y, r cos theta is the same as x. So this is the relationship between the Cartesian coordinates and the polar coordinates. So I'll have 9, where there's r squared, I replace by x squared plus y squared minus 5. Now r squared sine squared theta is the same as r sine theta, then squared. So r sine theta is just y, so you'll have y squared equals to 36. So this will give me 9x squared plus 9y squared minus 5y squared equals to 36. So which will be 9x squared plus 4y squared equals to 36. And if you divide through by 36, this equation would be x squared over 4 plus y squared over 9 equals to 1, which is the same thing as writing x squared over 2 squared plus y squared over 3 squared equals to 1, which is the equation of an ellipse. Then the second problem, if the equation 3x squared plus 3 minus pxy plus qy squared minus 2px equals to 8pq represents a circle, find p and q, and also determine the center and the radius of the circle. So this question was testing whether you understand the general equation of a circle. And so from the general equation of a circle, we'll be able to solve for any of these two unknowns. So we have 3x squared plus 3 minus p xy plus qy squared minus 2px equals to h pq. So note that equation of a circle is a x squared plus b y squared plus c x plus d y plus e equals to 0 if and only if a equals to b. So in an equation of a circle, the term xy is not present. So which means its coefficient, if it is there, then must be 0. So that means 3 minus p should be 0, which means p is 3. So that's the first value, p is 3. Now, another condition for this to be a circle, coefficient of x squared must always be the same as coefficient of y squared. So 3 must be the same as q. So the value of q is 3. So using now these two values, so using p equals to 3 and q equals to 3, we have the equation will be 3x squared plus 3 minus 3xy plus 3y squared minus 2 times 3x equals to 8 times 3 times 3. So we have 3x squared plus 3y squared minus 6x equals to 9 by 8 is 72. Then bring 72 to the left-hand side. So we have 3x squared minus plus 3y squared minus 6x minus 72 equals to 0. I can divide through by 3 and get x squared plus y squared minus 2x. 3 into 72 is 2, 4 equals to 0. So I have x squared minus 2x plus y squared minus 24 equals to 0. So now I complete the square for x and y. So x squared minus 2x plus minus 1 squared, which is the same as minus 2 over 2 square, is a b value, plus y squared equals to 24. But then for me to balance this, I have also to add this side minus 1 squared. So which will be x minus 1 squared plus y minus 0 squared equals to 25. So I'll have x minus 1 squared plus y minus 0 squared equals to 5 squared. So remember the equation of a circle centered at AB is of the form x minus a squared y minus b squared equals to r squared. So where center is AB and radius is r units. So this means that the center of this circle is 1, 0, and radius is 5 units. So give a polar equation of the graph r squared equals to 4 sine 2 theta. Given the polar equation of the graph r squared equals to 4 sine 2 theta, find its Cartesian coordinates or Cartesian equation. So r squared is 4 sine 2 theta. So we know that sine 2 theta is the same as 2 sine theta cos theta. So which means this will be the same as r squared equals to 4 into 2 sine theta cos theta, which is r squared equals to 8 sine theta cos theta. And also we know that cosine of theta is x over r, sine of theta is y over r squared is x squared. This is the relationship between Cartesian and polar coordinates. So I'll have x squared plus y squared equals to 8 into y over r, x over r. So I'll have x squared plus y squared equals to 8xy over r squared. So x squared plus y squared equals to 8xy over x squared plus y squared. I can cross multiply and have x squared plus y squared equals to 8xy. So x power 4 plus 2 x squared y squared plus y power 4 equals to 8xy. Then the next problem is to identify the type of conic section, find the center, foci, vertex, and directrices. So this first equation is 9x squared minus y squared minus 36x minus 6y plus 18 equals to 0. So we complete the squares to write this in standard form. So we have 9x squared minus 36x minus y squared minus 6y equals to minus 18. So we have 9 into x squared minus 4x minus y squared plus 6y equals to minus 18. So we complete the square for x here and for y here. We'll have 9 into, so completing the square means we have to take b over 2 squared, add, and then subtract so that the value of the original equation doesn't change. So x squared minus 4x plus minus 4 over 2 minus y squared plus 6y plus 6 over 2 squared. But then here, I'm adding 9 times minus 4 over 2 squared. So I have to add also this side 9 times minus 4 over 2 squared. Here, I'm subtracting 6 over 2 squared. So I should also subtract 6 over 2 squared. So then I'll have 9 into x, pick an x from here, then minus 4 over 2 is minus 2 square. Y then plus 3 squared is minus 18 plus 9 times minus 2 squared minus 3 squared. So I have 9 into x minus 2 squared minus y plus 3 squared equals to minus 18. Minus 4 squared, minus 2 squared is 4 by 9 is 36, minus 9. So minus plus 6, minus 18 plus But minus 18 plus 36 is positive 18 minus 9 is 9. So 9x minus 2 squared y plus 3 squared equals to 9. Then I divide through by 9 so that I get dividing through by 9, I have x minus 2 squared over 1 squared minus y minus 3 squared over 9 is the same as 3 squared equals to 1, which is a standard equation of a hyperbola. This is a hyperbola. Remember, hyperbola is written as x minus h squared over s squared minus y minus k squared over b squared equals to 1. So h is 2, k is minus 3, a is 1, b is 3, and remember c will be given by a squared plus b squared square root. So which will be 1 square plus 3 square square root, which is root 10. And eccentricity is c over a. So root 10 over 1. Then the foci, in this case, will be given by, so first foci will be h plus c comma k. So f1 is 2 plus root 10 minus 3. Second foci is h minus c comma k. So 2 minus root 10 comma minus 3. And then vertices, v1 is h plus a comma k. So v1 will be 2 plus 1 comma minus 3. So v1 has 3 minus 3. v2 is h minus a comma k. So v2 will be 2 minus 1 comma minus 3. So vertex 1 minus 3. Now for our hyperbola, question of the directrix, for this case, it would be x equals to h plus a over e, which is given by plus or minus. So we have x equals to 2 plus 1 over root 10, and x equals to 2 minus 1 over root 10. The second problem, B, we had 18x squared plus 12y squared minus 144x plus 48y plus 120 equals to 0. So we complete the squares to write this in standard form. So we'll have 18x squared minus 144x plus 12y squared plus 48y is minus 120. So it'll be 18 into x squared minus 8x plus 12 into y squared plus 4y equals to minus 120. complete for x, so we'll have 18 into x squared minus 8x plus minus 8 over 2 squared. I'll have to add 18 times this on the other side so that I don't change the values in the given equation. 12 into y squared plus 4y plus 4 over 2 squared equals to minus 120 plus, I've added this extra term multiplied by 18, so I have to also add on the right-hand side. I've also added this term times 12, so 12 over 2 squared. So I'll have 18 x minus 4 squared plus 12 y plus 2 squared, because this will be 2, is minus 120 plus 18 into minus 4 squared plus 12 into 2 squared. So I'll have 18 into x minus 4 plus 12 into y plus 2. When you add this, you get 216. Now divide through by 216, you get x minus 4 squared over 12 plus y plus 2 squared over 18 equals to 1. So, which is same as x minus 4 squared over root 12 squared plus y minus 2 squared over root 18 squared equals to 1. And this is the standard equation of an ellipse. Major axis parallel to the y-axis. So h in this case is 4, k is minus 2, a is root 18, which is the same as 3 root 2, and b is root 12, which is the same as 2 root 3. So remember, c squared is the same as a squared minus b squared, which will be 18 minus 12, which is 6. So c will be root 6. Eccentricity is c over a, which is the same as root 6 over 3 root 2. Now f1 is h comma k plus c. F2 is h comma k minus c. V1 is h comma k plus a. Then V2 is given by h comma k minus a, which is V2 equation of the directrices for an ellipse is, for this case, is y equals to k plus or minus a over e. And the equations are y equals to minus 2 plus 18 over root 6 times root 6 over root 6. So it's minus 2 plus 3 root 6 y equals to -2 minus 3 root 6. So that is the solution to that question.